So welcome back students. This is part 2 of arithmetic instructions. In previous part 1 we are studying add instruction, that is add register to the accumulator or from memory. Let us take an example. Fine. So in this example MVI a comma 47, that is A is directly stored in accumulator, that is A accumulator contains 47, then MVI B comma 54, 54 is in register B, add B, that is 47 plus 54 is added, that is 9B. Fine. This is how add instruction does. Contents of accumulator, that is 47, will be added with the contents of register B, that is 9B. So 9B nothing but sign flag will be set, remaining other flags are 0. Next one is LXI H comma 8050, means HL pair contains 8050. Move A comma 76, means accumulator contains 76. Then move M comma A2, that is A2 will be stored in memory location 8050, that is memory location 8050 contains A2. Then add M, means contents of accumulator and A2 are added here. Here it is the addition, it is 18. Actually the addition is greater than 8 bit, so carry flag will be set here. So CY is equal to 1 means the number is greater than 8 bit, and 18, it is 118, and the parity flag is also set because number of ones are odd. Fine. Parity flag is set. So these are the example. Fine. Next, this is example. Comes next one is arithmetic instruction, that is add ADC. So add with carry. If at all a carry is generated with any previous operation, the contents of accumulator, the contents of register and carry flag are added. Here it is written here, the contents of register or memory location and accumulator with carry are added. So let us take register contents, carry flag, accumulator are added, or memory contents, carry flag and accumulators are added, and the result is stored back in accumulator. Whenever it is given R and M, so ADC R means addition will happen with register contents, carry flag and accumulator, and ADCM means addition happens with memory location, carry flag and accumulator. If the operand is memory location, if it is M, the memory location is specified by HL pair. So HL pair contains the memory location. Which memory location? All the flags are modified to reflect the results of the operation. Example ADC B, ADC M. Fine. Let us see, is there any examples given here or not. So we can do add B, ADC B, ADCC, ADCD, ADCH, ADCL, ADCE. All are with respect to accumulator. So here what happens? Carry flag, register and accumulator, all three are added. If at all it is a memory location, it is carry flag, memory location pointed by HL pair, then accumulator, all three are added. Fine. Next comes ADI. I means immediate. Fine. I means immediate. It's a 8-bit data. This is 16-bit instruction where out of 16-bit, 8-bit is the data, remaining 8-bit is mnemonics. This is opcode 8-bit, remaining operand is 8-bit. Total this instruction ADI is 16-bit instruction. The result is stored back in accumulator. So 8-bit data, directly the given 8-bit data is added with the contents of accumulator and the result is stored back in accumulator. So all flags are modified to reflect the result of the operation. ADI 45H. This is the example. Let us see, is there any examples? Fine. Is there any examples? Here it is an example. So ADI XX So it is a 2-byte instruction. The 8-bit bit will be added to the accumulator. Assume the accumulator contains 4A, and these instructions add 4A plus 59. So accumulator contains 4A, that is converted in binary. XX data is 59, it is also converted in binary. So 4A plus 59 is A3. Here it is written, that is sign flag set here and parity flag set here, and this result is stored, A3 is stored back in accumulator. Fine. Next, ACI, add immediate to the accumulator with the carry. So I means again immediate here. So this is also a 2-byte instruction which will not only add immediately the given data, plus also it will add the contents of carry flag. Carry flag is added. So the 8-bit data and the carry flag are added to the contents of accumulator. So given 8-bit data plus carry flag is added to the accumulator, then the result is stored back in accumulator. So all the flags are affected to reflect the result of the operation. Example is AC5, ACI 45. Let us see whether we have any examples on this one. Then let us see here. So here it is carry flag, given 8-bit data and accumulator contents are added. Fine. Next, DAD. So this double add the contents of HL pair. Add register pair to the HL pair. Fine. So the 16-bit contents, here it is a register pair they have mentioned, means it's 16-bit. It is a register pair. So 16-bit contents of register pair are added with the HL pair. So we can use a register pair, like what are the different register pairs available? BC, DE, HL. So we can add BC with HL, or we can add D with HL, or we can say, or we can add HL with HL. The result is stored again back in HL pair. If the result is larger than 16-bit, then the carry flag will set. No other flags are affected. Let us see some examples here. Is there any examples? 1 minute. So when we add two register pairs, that is it may be BC or DE or HL. So these two register pairs can be added. If the result is greater than 16-bit, then carry flag will be set. For example, DAD B. What happens? BC pair will be added with HL pair. If I write DAD D, D pair is added with HL pair. If I write DAD H, so HL pair is added with HL pair. This is how it works. Then comes next subtraction instructions that will be covered in part 3. Please follow the part 3. Fine.